Hello everyone, welcome to another live stream. Today we are going to work on some model that needs some refreshment. It is outdated model of front suspension of right wheel, and this is actually the model that we want to update for some time, and now it's time to start working on it. So first, what I want to do is actually to open this outdated model and to inspect it and check out if there is something that is well built, is there something that we are going to keep it, or is there something that we need to change or to modify, to update. And let's see how it goes. Okay, here is the model. So this is the right wheel. This is not only suspension, it's also the rim and the tire. So when I look at the parts, I can notice that there is no shaft. So this is suspension of a rear wheel drive car. So this is front suspension, but the car has a rear wheel drive. What is the type of suspension? It is double wishbone. This suspension is used for some performance cars. So let's look at the model itself. To me personally, this rim does not look very realistic, and it should be replaced completely probably. And also if I'm going to replace the rim, then I'm going to replace also the tire. So this is something that we are going to work on, maybe not today, but let's see what we can do today. So let's hide this and see what is underneath. Okay, now we can see the brake disc, which looks kinda okay. So maybe we can use this, and if I hide it, underneath there is something that looks a bit incomplete, so we would need to work on this. Let me turn on the section view and check it out. So this wheel hub is not built very detailed, so this is the part that would need a lot of change. And there is the bearing, the seal, but if we look at this assembly, this seal is actually pointless at this place. So this is also something that we can work on. So for today, probably most of the time I'm going to spend on wheel hub, on bearing, on disc brake, and that assembly of a wheel hub. And maybe if we got enough time, I'll try to model the knuckle, this part. So today I'm not going to touch the brake, but brake itself looks okay. It has a lot of parts that should be there, but for now the incomplete part is actually the wheel hub. So now I'm going to, and also if you look at the rest of the suspension, we can see that there are some interferences and some incomplete design of some assemblies. So it looks to me that most of these parts will need at least some modifications, but probably I will need to replace those parts with some new parts. So I would need to modify new parts. Okay, now let me open the picture of that assembly, so it is a bit more, sorry about that. Okay, let me open the picture so I can explain a bit better what am I going to do and what are we working on. So this actually, let me put it somewhere here. Okay, this is actually how those parts should look like. So there is the hub, this is this green part, and we can see that there are no bolts, there is no hole in it. It is very roughly designed in this case. There is splash guard, which goes between knuckle and hub, brake disc, which is, as I said, kind of okay. So we could reuse the brake disc, but we need to design bearing, snap ring, hub, and splash guard. So let's start with removing the hub. And if you look at this bearing, sorry, now let me change the view of the section view. If you look at this bearing, there is only one row of balls, which is also not good presentation of how it is usually on suspension. So I'm going to create another bearing with 2 rows. So that would be actually the part that I'm going to start with. And also this part is something that is completely not realistic, so there is no such part on a car, especially on the rear wheel drive car. So this is also something that we need to change. So let me remove parts that we don't need. Let me see, there is like this. This bearing is important. Okay, now I'm going also to remove the seal, and this weird part is also not necessary. Okay, what I want to design first is bearings, so I'm going to start with, let's add offset here from this or even more. Usually the mistake that even I sometimes make is that when you do something like offset or offset edge, offset face, sorry, or move part, and if I did not move it to the place that I would like it to be, then usually it is the easiest to just click on it again and then move it again. But in that case, if you look at design history, sometimes this will create multiple steps. For example, now I'm creating new offset, here it is, and if I want to modify it and I click on it again and move it, that would create another offset, and with that we are doing two steps, and this can slow down the model because the history fills up with a lot of steps that are unnecessary. So in that case, if I already did, for example, created this plane, I don't want to click on it and move it because that will create this movement step. Instead of it, I want to click on the plane. That's the step where I created the plane, and now I'm going to edit the distance that I typed in previously. Now there is no additional step in design history. With that in mind, you can keep your design history clean. Sometimes it is a little bit slower if we look at short-term goals, but it will make your model run smoothly after when the model is more complex. So keep that in mind while you are modeling. And also it is natural to make that mistake. Okay, so there is the plane. I'm going to start sketch on that plane, and let's use this knuckle as a reference. Okay, this will be our starting point. I'm going to draw a circle, and circle is going to be, let me just check what dimensions of bearing should be because I don't have it in my head. It should be 42. So this is the, and let's make this circle construction because I don't want that circle to create profile with another circle. Okay, so that's the inner diameter of the bearing, and maybe this is actually not best approach to start because my bearing has some profile, so I'm not going actually to start with the circle. Yes, I'm going to use this plane. I'm just going to rotate it by 90 degrees, and here I'm going to start sketching. Okay, let me create horizontal line, which will be construction line, and that line is going to be the axis that I'm going to use for revolution. And now I'm going to draw a profile of a bearing. So let's start with this here, like this, and yeah, probably like this for now. So this is for inner part of the bearing. The outer part of the bearing should be higher, of course. Oh, sorry. I'm going to modify those two lines, don't worry, and the width should be way more than 12. So here there will be one row of balls and then another row of balls. So what should we need? Let me just open reference on my laptop if I have it. Okay, the part that we will need is, I think this will be okay for start. So if I select those two profiles and use revolve, we will have this shape. It is slightly bigger than everything else, so probably I will adopt everything else because it can be the case that it is out of proportion completely. But for this bearing I'm sure that dimensions are right, so I will build model around it. Sometimes it is very hard to get to data about some parts, especially when the assembly is complex and when there is a lot of parts. It is hard to find data on the internet. You can find it in some PDF documents about, for example in this case, about maintenance of the car or user manual. So that's how usually I look into dimensions or data about the model that I'm going to build. Or if the data is not very available, and that can happen very often, I usually start with parts that I am completely sure and that are completely available on the web or from some other person who works in that field, or from books, whichever reference. So I will start with bearing because I'm completely sure that bearing is something that you can check up on the internet and then build everything around it, because dimensions for this part is impossible to find on the internet. So that's maybe also why there are a lot of mistakes for this part, but we are going to try to build it as accurate as possible. So let's continue with our bearing. I'm going to turn on the section view, but here. Okay, another thing that I'm going to do is create another sketch in the same plane, and this another sketch will be actually, let me project those two lines, because, and we'll use it as a reference, I'm going to, that way I'm going to create middle line, lock it, and for some reason, and now I can actually see what is the reason, those two, if I connect those two center points with line, you can see that clearly it is not vertical. And if why is not vertical? Because those parts, even though they look like they are vertical and horizontal, they are not, because if you look closely to this part, which we used as a starting point to create the plane, this part is also not aligned. So that's reason why now everything is off this alignment. So that was mistake to use this already existing part to start to create plane and to start working on it. So we need to quickly fix it. Probably the easiest way to fix it is just to go back enough and do this thing again, but on plane which is on plane which is not tied to this part, because obviously this part is not aligned. The construction line, and those are actually things that actually happens in modeling when you import some model or you start working on some model that you designed previously. You did not have enough time to pay enough attention to details, and then you actually can see where are the mistakes that you made or that somebody else made, and now you need to work around them and to adapt your model to actually the model that needs some corrections. And sometimes it's even easier to design something from scratch than to adapt model to what am I doing? To adapt model to something that somebody already did. So let me use this plane, and I'm going to move it here. And probably because I'm going to completely redesign this part, this position of this plane should not be as accurate as possible, because this is actually now our new starting point, and from that point I'm going to design everything else, and probably this part and probably the brake. So that's why am I putting it almost randomly in the space. So let's start again. I'll use this just as a rough reference now, because I previously saw that it's not a good idea to use it as a real reference, because it is not precise enough. So this is the model that I'm not seeing first time. It's not my first time seeing it, but this is my first time working on this model. Okay, now we should be alright with it, and this is the previous sketch. I'm going to remove it, and okay. Now finally we are back at the point where we were previously. Okay, nice. this. Now the interesting part is that those two parts also does not look aligned because of the grid, so maybe it may seem that it is not completely parallel, but it is. And now I actually can those are construction lines. And finally, we are going to design balls. Okay. So I should fix this, and then I am going to define the position of it. And the important thing that I want to do before I create balls is that I want to revolve and create those two bodies. And what am I going to do now is use those bodies to create shape of the bearing. Now it's not very clear what is going to be the result, but let's check out. Okay, that's exactly what I wanted to do. And now I want to do this with other half of it. Okay, it looks okay. Now when that's done, I can select this and use revolve. Now we can use pattern. For 360 degrees, and let's put, for example, 15 rolling bodies. Okay, let's change view again to this one, because this is not yet how the real bearing looks like. So this part and this part should be aligned here. this, and also the lower part is from there is the new plane, here it is. So I also need to split the lower part in two parts. And of course usually there is the fillet on those edges, but let's not add it yet. That would slow down the model. We are going to add it at the end when everything is done, when all of the parts are done, not roughly, this is precise enough, but without such a details that are not crucial at this point. So now when we have bearing, let's see what is next, what we should do around it. So there is wheel bearing, and the next part that I would like to design is hub. So the hub is the part that goes inside the bearing, and you will see how the hub for this particular car that I'm building for looks like. Let me just open another picture. So actually let me first show the whole assembly. Here it is. So this is the knuckle. Here this part is a tone ring. It is for ABS, and below that ring is the spindle nut, and below that spindle nut there is the bearing. So, and on the other side there is this splash guard and wheel hub. So we are going to work on wheel hub now, and wheel hub looks like something like this. So this is the part that goes towards the wheel, and this is the internal part, and we can see that it kind of looks like the part that we removed, but it's way more complex and it's very different than that part. So this is the next part that we are going to design around this bearing. So let me just move it away and start working on it. I'm going to start now. I'm going to create another plane, because there will be some parts between bearing and also between wheel hub, so I will leave some space for that to come. But the important dimension that we need to use is actually the inner diameter of the bearing. Okay, let me switch section view to display. Nice. Now let's start with profile. Let's look at the profile of the wheel hub and sketch it roughly. So I will use this, because that way now I have this reference. So this is important for me. I'm going to lock it and make it construction. And let me start with the wheel hub. So first thing, let's start from this line to, for example, 50. 50 millimeters, and now let's move a bit higher, 10 millimeters, and then again, for example, 4 millimeters. We are going to modify this later. I just want to create the shape of it. Later we can easily, with dimensions or with direct modeling, we can modify the shape of the wheel hub. Oh, sorry about that. And here we also need something like this. Okay, so that's roughly the shape of it. Let me just check out if everything is horizontal. Okay, I'm going to remove this. Not to remove this, but to hide it, so it is not in the way. Later we are going to work on the knuckle, maybe today if we manage to do it, or maybe on some of the next live streams. So now let's get back to the profile, and let's check if this makes sense. This is definitely too long. This one should be a bit bigger. I won't lock that up yet because maybe I'm going to move it across the horizontal line, so that's why I'm not locking it. This should be alright. Oh, now I noticed that this actually is not in the middle. So how am I going to fix that? I'm going to create this reference. Okay, now I think we have correct shape. I'm still not very sure about this part, so this should be a bit smaller. Okay, let me remove sketch so we can see our part. So this is actually the wheel hub, and as I said, it should probably be more moved to the right, but let's not do it yet. Later we can easily move parts around. Let's make it there so we have enough space if we want to add something, because we are definitely going to add something in between. And let's check if we have enough material here for the holes, or we have maybe too much of a diameter. So the dimension that I'm completely sure about is the distance between holes. So let me create hole here. So this is actually the position for holes, which is okay. Okay, and I think we have a bit more material than we need. So this, we can move it a bit down. Yes, like this. And make it a bit thicker. Okay, now when we have one hole, we are going to use that hole and to use pattern to create other. In this case 4 holes, sometimes it can be 6 holes, so I'm going to create variable so we can later maybe modify this hub to 5 or 6 holes depending on the wheel that we want to try on it. Of course, in reality it's a bit different. The wheel will adapt to, I mean, we won't try 6 hole wheel on 5 bolts wheel hub, but in terms of modeling we can use this model of this suspension for multiple cases. So that's why I want to create it a bit parametric, not completely parametric, but a bit parametric, so we can play with it later. So I'm going to use a pattern in this case, circular pattern. This will be the axis, and this I want to create a number of holes, and angle should be 360 degrees. For now, we are going to set it up to 5. Later, as I said, we can try it so it is 6. And also the thing that I don't like is the thickness of this part, and also I would like to add those details, add chamfers and add thread at the end of it. So this is what I'm going to work on now. So there are two ways. One way is to use offset, another way is to go back to sketch and edit it here. Sometimes I use direct modeling, sometimes I use this approach when I want to create a model that is a bit more stable and that is a bit faster later. I would usually correct some things like this and not with direct modeling. Let's isolate this part, and now let's add some details to it. So here what I want to do is create this, and those are just reference lines. What should be the angle? So it should be 6. That is definitely not good enough. Okay, this is perfect. And now the important part is, if I want this shape also to change with the number of holes, I should again use pattern and connect it to number of holes. And also important thing is that be careful that when the number of holes are going to change, the distance between those holes are also going to change. So we can, for example, set it a little bit lower and see if this will work out, or we can calculate dimension of the diameter also to change with the change of number of holes. But for now Let's try it with this approach and see if that would work out. Oh, I selected accidentally reference lines. So we have the shape, and let's do that. Okay, let's see what will happen if we change this to 6. For some reason, we have missing, there is missing one, and I exactly know what is the reason. Because in this, if you look at sketch, there is still this sketch which is not used. So in this case I need to edit this and also add let's see, I want to try something a bit more different. First thing that I want to do is change the number of holes, and now I'm going to edit this sketch, and I'm curious if this would work if I change holes to a smaller number, because I'm completely sure that in this case there will not be the case where there will be more than 6 holes. So let's create the case for that. Let's create the model for that case, and it should work when we change the number of holes to 5. But let's see if that works. So again, now let's hope if I change this to 5, this works, but let's see. Oh, sorry. It should go other way, like this. And in that case it works. So when there is the case, when you know what will be your upper range, then you do it for the upper range, and then when you scale it down it should work. And if I change it to 4, it still works. So okay, we are going to continue with 5, and yeah, now I'm curious if I add fillet. I know that I said that the fillet should be added at the end, but when we are doing something parametric, then the order is very important, how we do something. And let's see if this will should work when I change the number of and it happened again exactly the same thing that happened previously. So what is the solution? The solution is to set up the model with the higher number and now when I lower the number it should work. But in this case the application is looking for that fillet that we created because it could not find the edge because that edge disappeared. So with this fillet it is a bit tricky because you will get the warning message and then you will need to remove it from here. So it is not very stable, so maybe this in this case then it does not make very much sense to add those fillets, because later now we know that this warning message is about that, but when somebody else use the model, for example few months after this, that other person maybe will have hard time to figure out why does it not work. So now we are going to leave it like this, and at the end we are going to add fillets, and in that case at least we are sure that the model will be stable for this particular use, and for other use those fillets can be also added at the end if it is needed. So why is it not in the middle? Oh, so there is other problem now, because I set fixed angle here. So yeah, this angle is 36. How should we define it? It should be 36 divided by this, and let's see if no, but close. Okay, so we defined the same angle, but we used the number of holes, so now it should be connected, so it should keep in middle this shape when we change the number of holes. I hope so. So we can continue with other stuff. So the moment of truth. Yes, finally it works. So usually the modeling takes few iterations to come up with solution that actually works. So this is easy part compared to the part that we did previously. Usually when parametric is and variables are necessary, it takes a bit more time to define relations between some parts or some features. Now I want to create a thread. So the distance is 29. The pitch should be 1.5 millimeter. And if I want, for example, if I multiply this by 29, in this case the pitch would be 1 millimeter. If I want it to be 1.5, then there should be smaller number of rotations, so smaller number of 360 degrees. And how can we do that? By dividing it by the pitch that we want. So I want it to be 1.5, and when I input it, now there is the thread that I wanted to create. Subtract, and the part that I want to keep is this one, and I want to remove the coil. Okay, and usually when the thread is created, there is this end of thread, which also needs some treatment. So I am just going to click on it and use extrude, and let's say extrude it for 30 millimeters on the other side, and that's how you finish the thread. On the other side, it is also nice. So with that, I think this part of the wheel hub is done. Okay, and here we will need to add some small details. Okay, that should be it. So this is wheel hub. Other thing that we want to design here is bolts. So let me show. It is a bit, those type of bolts are a bit different. So here is it, and the detail that we can notice is this detail here. So it's regular bolt with this little detail. So we are going to design that. Let's use wheel hub as a reference. So I'm going to start sketch, and maybe I don't even need to project this. Or this is too big. It should be something like this. And in this case, what happens is when there is the hole and there is the sketch around it, when you try to select this profile, this in this case it will select just this part of the profile and not the part where the hole is. What I do in that case is just use a section view and see if that would help. If this does not help, then I isolate the sketch, and in that case I just perform the extrude, and here we need to add this detail. Okay, go back, and now let's, for example, we can, because now in this case there is no sketch here, we can quickly create it by clicking on this edge, project, and then click on this face, and now we have a sketch for it. In this case, to me, it seems like the dimension is not right. So let me see what can we fix. If we go back to which sketch was it? No. Yes, that one. And if we fix this to 12, will everything else broke or no? No, nice. And let's remove this. What I forgot to do previously, that's why bolt did not change, is to click linked sketch. And now when I project it here, and when I extrude it, if I change the dimension of hole, the bolt should change also according to that change. So let's see if that works now. Yes. So keep in mind when you are using projection that you need to link projection to the existing sketch, so when you change the sketch, the projection will change according to that. So this is one part. Also we need to add fillet here. Chamfer, and we need to add thread also, and also those little details. So thread, we should add it by using the, I think we can use already existing plane. That one we are going to use section view, but the other one because there is nothing behind it. Start sketch. Again, I'm doing the same workflow I did for the wheel hub. Okay, I made a mistake, but we're going to fix that. Just click on it and select horizontal. Important thing is that those two lines are symmetric, and also angle between those lines is also important. It can be different depending on the standard, but wrong direction. Let me change direction quickly. Okay, that's it. And last part. Make sure to make it constrained, because if you do not, then let me show you, when you, for example, let's define this completely. And now if I want to use this profile, I have actually two separate profiles, and if I want this to be only one profile, I need to make this construction line, and now it is only one profile. And it is probably too small, but if you set constraints right, it is easy to change dimensions, but obviously I did not set it right for some reason. or I did, but I probably did something wrong last time. Okay. Now that will be perfect. Okay. I want to make it new body, and the thing that I want to do is this. I want to change the orientation of this face like this. I want to do the same for this side. Oh, that's not what I wanted to do. Definitely. I am a bit lost now. Definitely it is too big, so now I can also change it, even when I did the pattern. Still it's very this, and we will add a lot more with pattern. One bolt. We need to perform union. If you accidentally select sketch while you're selecting bodies, the union will not be available here in tool selection, so be careful. But for some reason this body is also connected. So I need bolt and I need circular pattern. We can hide the sketch. Also important part and important thing while doing modeling is actually to name all of those bodies accordingly, but now because I don't want to spend time on it, I will do it after the stream. That's why I'm not renaming everything, but I would highly suggest to rename everything according to its parts. It takes some time, but later you will have a model that is well organized and well designed. Let's turn on. Okay, now you can guess what I need to do with this bolt. I need to use pattern again. And number of bolts will be same as number of holes. So now this wheel hub is way different than the one that we had at the beginning. Let me just check out if there are some details that I missed, but to me it looks like it is very close. There are two holes that are missing, but we are going to add it later when we add some different parts. Okay, this looks nice. What I wanted to check is what will happen if I change the number of holes now to 5. Will this still works? Usually when you are doing something with variables and parametric, I would also advise to every time when you are doing some modification on parts that could be sensitive to change of parameter, you should write after every change and see if those things that you did after the defining the variables will mess up the model. But in this case everything works perfectly, so we can continue. Let me just see what would be next thing that we can do. Probably the part that we are going to design now is break disk, because we have just enough time to do that, and the last break disk was smaller than the one that we need, obviously, and probably I'm not sure if this break will be good enough, but when we are done with suspension parts and everything, then I'm going to work on brakes. So for now I don't want to touch this part of assembly. I just want to finish the wheel hub, and that's why I'm going to add brake disc in this case. So let's design it. So first, how are we going to start? We are going to turn on the plane that we used previously, and we are going to start sketch, so we can create a profile, turn on the section view. That should be the easy part, modeling the brake disc. Now this interference is the detail that we added to bolt. We can perform just subtraction to remove it, but those little details are there to actually keep the bolt connected to the wheel hub. So there is some overlapping in assembly, so let's keep it that way for now, and later if we want to do something with it, we are going to do it. But now let's focus on brake disc. So next thing that we want to do is to create profile that we are going again to revolve around axis, and axis is going to be here. Okay, how does, let me show you what are we creating, but you probably are already aware of it. So this is the brake disc that I'm going to create. So those are holes for bolts, those are some other holes. We are going to add those later. They are there for positioning the brake disc. So that's what am I going to work on. Also, the as you saw on break this, there are also holes for bolts, and that's those bolts that we designed. So this also should be parametric, so we can change the number of holes according to number of bolts and holes on the wheel hub. So that's why we will need a bit more time than we would need with non-parametric model, but I'm going to show you now how to do that. So we are going to use this face as a reference and start with simple line. This simple line should go like this, and here so the important part is the break this diameter. Diameter should be 300 millimeters, so the radius is 150, and let me change this dimension to, for example, 4. Okay, and I will use this sketch that I created, and I will use offset tool to create offset sketch from it, like this for now, and then this breaking part should be a bit thicker. So if you look at the picture, you will see that this part is a bit thinner, but there is other part which is the braking surface, the friction surface, that should be thicker, because that part is going to wear, so it has to have there should be a bit more material. Of course, friction material, it's not the same material as hub. Okay, let's try with it like this. Important thing when creating profile with offset, at the end of offsetting you need to close the profile so you can use it like this. And now I can use revolve to create that shape. I'm going to hide this. The thing that is obvious is that brake is too thin in this area, and also what we can see is that there are no holes here. Why I don't want to use just subtract? because in that case I'm going to have threaded hole and I don't want that. So I want to have just hole in that part of the break disk. So let's change the thickness of only this part. So what I want to do, I will click just on this part, on this surface, and I won't use offset, but I can. So what is the difference actually? The difference is that when you use offset, then if you look at this part here, it will adapt automatically to the hub. Or if you want to use extrude, you can just click on face and click extrude. And what is the difference? This is the difference actually. So now it is, in that case it is a bit different. So what I want to do, or I can actually do it on the other side, because there is the friction material here, let's say for 6 millimeters. Okay, and the other thing that I want to do is I don't need extrude probably for this, but extrude it for 4 millimeters. Oh, not new body, but union. Okay, it's still one body. And what I want to do is to project this in that face, and now I have profile that I'm going to extrude and union. So the thickness is same. Okay, now what I want to do is I want to create those holes. How am I going to do it? Let's isolate those two parts. Or do I even have to isolate? But I can click on this hole, and I'm going to project this hole on this face. Important thing is that the sketch is linked. Press OK and enter that sketch. Normal to sketch. I want hole to be a bit bigger than that one. So I'm going to make this whole construction, and it will be 14 millimeters. I want to isolate break disk, and I want to isolate this sketch that I just created. Create the hole, and now let's again use pattern. .360 and here, but now I made mistake similar to previous one, but in that case I think it is not even matter. So let's see. So when I click on this hole and I find pattern somewhere here, where is that sketch that I want to turn off? There it is. Okay. So this looks good to me, and if we change number of holes, so number of bolts to 6, it should also work, and it works, yeah, because that was pretty simple model. I mean disc brake. So if we turn on the section view and inspect it to check if everything is alright, there is no interference except this little interference here that we are aware of, but we are going to leave it there for now. Okay, and let's add some details here. I'm just adding ribs there. And with that we designed wheel hub, we designed pairing, we designed disc brake, and we designed also bolts. Everything is, oh, I forgot to connect those. Everything is parametric. I mean, not everything, but the number of holes and number of bolts, so we can try different wheels later when we are done with model. And for now I think that would be nice progress from what we had. So we are going to finish this model. It will take few iterations, so it is not a simple model, and it takes a lot of time to investigate all of the parts, how to design those parts, and also it takes some time to design them, especially if we want to have some parametric features, and those are not the only parametric features that we are planning, so it will take time to design the whole model, or to redesign the whole suspension. So let's check what is left from this assembly. We will have assembly. So in this case we don't have this spindle nut, because this spindle nut will come on the other side in this case, because this is not the driving suspension axle. There is no axle because this is not driving wheel, so it's driven wheel, so that's why there is no room for axle. And if you look again at the picture, this picture is not actually the most representative one, because we are not trying to create exactly this assembly, but this is just to show you roughly what we are going to do. So next thing that I'm going to do is to add those holes. Next time when I start with modeling, start with those holes, start with splash guard, which is one part, but it is a bit more complex, because a bit more complex surface, but nothing crazy. Then I will need to design snap ring, wheel bearing we already did. I'm just going to design seal, and after that there is knuckle, which is pretty complex part. It is single part, but it has a lot of features, so it will take some time to create that one. Maybe we could do that on some of our next streams, we'll see, but there is still a few parts that we need to model to finish just this one assembly. So that would be it for today and for this year. Thank you so much for your attention. I hope that you will be there when I'm going to stream next time. So thank you very much, thank you for your attention, and see you next time.